Let's create the Lewis dot structure of NO, better known as nitric oxide. We can follow these simple steps to accurately depict the Lewis structure of NO. First, we'll sketch a rough diagram of the structure. Next, we'll illustrate the chemical bonds between the atoms. Then, we'll find the total number of lone pairs and mark them on the structure. After this, we'll ensure that the octet rule is satisfied for each atom. Finally, we'll evaluate the stability of the structure and aim to achieve the most stable Lewis structure with the smallest possible formal charges. To draw a rough sketch of the NO Lewis structure, we first calculate the total number of valence electrons and then identify the central atom. The total number of valence electrons in NO can be calculated by summing the valence electrons of each atom. Nitrogen, a group 15 element, has 5 valence electrons, while oxygen, a group 16 element, has 6 valence electrons. Since the NO molecule consists of one nitrogen atom and one oxygen atom, the total number of valence electrons is calculated as 5 plus 6. This equals 11, meaning the NO molecule has a total of 11 valence electrons. The central atom in the NO Lewis structure is determined by selecting the element with the lower electronegativity. Nitrogen has an electronegativity of 3.04, while oxygen's is 3.44. Since nitrogen has a lower value, it is chosen as the central atom. Thus, the rough diagram for the NO Lewis structure can be drawn by placing the two atoms in a straight line, as there are only 2 atoms involved. 2 electrons represent a single chemical bond. In this diagram, we will place 2 electrons between the nitrogen and oxygen atoms to represent a chemical bond. As discussed earlier, we had a total of 11 valence electrons. Now that 2 electrons have been used, we are left with 9 electrons. Lone pairs consist of electron pairs that are not involved in chemical bonding. Remember that each pair contains 2 electrons. As discussed, there are 9 unutilized electrons. From these, we can form 4 electron pairs and mark them as lone pairs on the structure, while the remaining 1 electron can be marked as an unpaired electron. It's important to remember that both nitrogen and oxygen are period 2 elements, and they cannot hold more than 8 electrons in their valence shells. Make sure to always start marking lone pairs on the outer atoms first, before proceeding to the central atom. In the NO Lewis structure, the oxygen atom, being the outer atom, is first assigned 3 lone pairs. The remaining 1 lone pair and a single unpaired electron are then placed on the central nitrogen atom. The current structure clearly shows that the outer oxygen atom satisfies the octet rule, but the central nitrogen atom does not. Let's work on completing the octet for the central nitrogen atom. It's important to note that nitrogen is a period 2 element and cannot hold more than 8 electrons in its valence shell. As shown in the diagram, the nitrogen atom already has 5 valence electrons. Therefore, we will convert 1 lone pair from the oxygen atom and transfer it to the nitrogen atom to form a chemical bond. In the current structure of NO, the outer oxygen atom forms a complete octet, while the central nitrogen atom does not. However, as discussed earlier, nitrogen is a period 2 element and cannot hold more than 8 electrons in its valence shell, so converting another lone pair into a bond is not possible. Therefore, we will now calculate the formal charges of each atom to determine whether the current structure is stable. This is the formula we can use to calculate formal charges for the NO Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Just input the data and insert the values to determine the formal charges for each specific atom. For nitrogen atom, valence electrons equals 5, non-bonding electrons equals 3, and bonding electrons equals 4. So, the formal charge will be equals 5 minus 3 minus half multiplied by 4, which equals 0. For oxygen atom, valence electrons equals 6, non-bonding electrons equals 4, and bonding electrons equals 4. So, the formal charge will be equals 6 minus 4 minus half multiplied by 4, which equals also 0. The formal charges on the nitrogen and oxygen atoms are indicated on the structure, and it is evident that both atoms have a formal charge of 0. Hence, this structure can be considered the final stable Lewis structure of NO. To represent a bonding pair, we draw a single line between the atoms. In this structure, two pairs of electrons exist between the nitrogen and oxygen atoms, so we draw two lines between them to represent a double bond. Therefore, the final Lewis structure of NO has a nitrogen atom double bonded to an oxygen atom. So, that's the Lewis structure of NO. If this explanation was helpful, please give it a like, share it with others, and subscribe for more educational content.